Question 8 uses z-scores to compare two different values in two different normally distributed data sets. The question doesn't tell you that this data is normally distributed, but we can assume that it is in this context. So it says that in the 96th Grey Cup, which is the championship game of the Canadian Football League, Henry Burris, who was the quarterback for the winning Calgary Stampeders, had a passer rating of 99.8. In Super Bowl 43, Ben Roethlisberger, who was the winning quarterback for the Pittsburgh Steelers, had a passer rating of 93.2. Now, during the Canadian Football League's playoffs, the mean quarterback rating was 78.17, and the standard deviation of that data set was 24.7. And during the NFL playoffs, the mean quarterback passer rating was 69.48, with a standard deviation in that sample of 22.4. So we want to compare these two, and because this is normally distributed data, the best way to do it is with a z-score, and this is in section, I think, 3.4 of chapter 3. You can find it in the book, you can find it on the slides, or you can see it's right here. Now, for this question and for many questions that will follow farther along in the semester, I recommend that you make a legend. You make a list of the variables that you're given in the question. And so, because then you can see what those values are and you can plug them into your formula, and away you go with your calculations. So I've made a list of Ben Roethlisberger's numbers, his passer rating, and that's the individual value. The individual value goes here. His rating 93.2. The mean for his league was 69.48. That's the sample mean here. And the standard deviation is 22.4. So that goes here when we make our calculations here in a moment. You can see them down here. I do the same thing for Henry Burris and list all the values for him. And then when I have these values listed out like this, when I have this legend put together like this, then I can see where to plug each of these in to the formula that I'm using. And so when I subtract 69.48 from 93.2 and then divide by 22.4, that will be 23.72 divided by 22.4, and we get 1.0589 something something something, which, because this is a z-score, we round to 2 decimal places. Always round z-scores to 2 decimal places, for reasons that we will see later when we cover chapter 6. Now, that's Ben Roethlisberger's z-score. When we do similar calculations for Henry Burris, we get a z-score of 0.88. So Roethlisberger did better relative to his league in his team's championship game than did Henry Burris. And here's a graphic reminder of what these scores mean. We're standardizing these scores to the same scale. If this normal distribution represented the NFL's statistics, then this mean would not be 0. It would be 69.48. And 93.2 would be Ben Roethlisberger's score over here. Similarly, if this distribution represented Henry Burris's, this mean would not be 0. It would be 78.17 right here instead of 0. And then his passer rating of 99.8 would be over here, right here where the 0.88 is. But when we standardize them, this allows us to put them on the same scale, and we can see that here's the mean. They're both above average because they're on the plus side of the mean. But Ben Roethlisberger is a little bit higher. He's a little bit farther above the mean than Henry Burris is, so he did better. So that's how you use z-scores to compare two values in two data sets. All right, now question 9. Question 9 asks us to find percentile. We're first asked to find what percentile. Actually, the question that I gave here doesn't do that. It refers to examples in our text. But what you will be asked on the test is to find the percentile of a particular value. And examples 3 and 4 on pages 115 and 116 are these examples right here, and this is exactly what you'll be asked to do on the test. So we're asked to find the percentile of 23. And so here's the formula for that. You're going to probably want to include that on your notes. It's really just this formula right here, reformed, restated algebraically. You move things around and you come up with this. The percentile of value x, which is the k here, equals the number of values less than x. And that's going to be the n here. Well, and then we divide by the total number of values, and we multiply by 100 to give us a percent as opposed to a decimal, a proportion. So we're finding the percentile of value 23. How many values are less than 23? Well, here's 23 right here. There's actually several of them, but there's the last one, or the first one on the list, depending upon which way you're counting. And so how many values are there below 23? Well, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there's 10 values that are less than that 23. And since we can see that each row has 10 and there are 4 rows, we know there are 40 values. This example, by the way, is also shown in the slides for section 3.4 that I posted on our website. So we divide 10 by 40 and we multiply by 100, and that gives us 25. So the percentile value of 23 is p subscript 25. P subscript 25 means the 25th percentile. And as I said in question 2, if this symbol was listed as one of the symbols that you should, notation symbols that you would have to identify, you would want to identify it as the 25th percentile. Don't just say percentile, say that it's the 25th percentile for the 25 there. Excuse me. Now in the second part of this question, you are asked to find a particular percentile. What value is, in this case, the 18th percentile? Well, to do that, use this form. This L is a locator. K is the percentile in question, which, as I said, is 18. We divide that by 100 and multiply by the number of values in the data set. Well, 18 divided by 100 times 40 is 7.2, but 7.2 is not a locator because it's not a whole number, so we round up. We round up to 8. So then we count 1, 2, 3, 4, 5, 6, 7, 8 to the 8th value in the set, and that 8th value is 22. And so the locator is 8, the 8th value is 22, and since the 8th value is 22, the 18th percentile, P subscript 18, is 22. So that's how we find those values in this question. I'll show you in a minute a quicker way to do this in Excel. And now the last question asks us to draw a box plot. And the question on the test, which I will, or the question on the practice, or the data set, the Excel data set, the Excel spreadsheet, uses a different set of values than this chocolate chip example does. But on the test, I will ask you to refer back to the values that were used in question 9. So, my program thought I misspelled box plot because it doesn't know the word. So here we go in number 10. We're asked to use those values to construct a box plot. So what is a box plot? Well, a box plot shows us 5 particular values. It shows us the smallest value, the minimum value in a data set, the maximum value in a data set, and 3 values in between. Excuse me, sorry. The values are the quartiles. Quartile 1 means the 25th percentile. So there's quartile 1 right there, identified with a capital Q sub 1. So quartile 1 is the 25th percentile. It's the value at or below which 25% of the values in the data set lie. Quartile 2 is the 50th percentile. It is the value at or which 50% or below which 50% of the values lie. And the Q3, the third quartile, is the 75th percentile, and that is the value at or below which 75% of the data values lie. So this cuts the data set into quarters in terms of the proportion of values contained below each. So to do this, we find the 50th percentile in a fashion similar to what we did here, and we find the 75th percentile. Turns out we've already got the 25th, which is quartile 1 from our example above, and then on a number line, we want to mark off those 3 values, and it turns out that 24 is the so we know 23 is the first quartile, 24 is the second quartile, and 26 is the third quartile. So we mark each of those on a number line and draw a box around it, and so there's our box plot. And this shows us that the data values here are fairly normally distributed. I mean, they may not be exactly, but they're pretty close to normal. So that's fine, but I think it's useful to repeat this process for the set of values that's actually on the spreadsheet here, because it's a much larger set, and you might want to know how to do this using Excel. So all of this data corresponds to questions 9 and 10. It says IQ led. This is yes, this is IQ. This is from the IQ led spreadsheet that we used earlier, except this is a different column, IQV. The other was IQF, and this is IQV. Now, these are the locators, and they are in order. I would like to order all the values in my data set to correspond. And here's how I'm going to do this. Please watch and listen very carefully. In order to do that, I'm either going to type or select. Actually, it's better if I select all of the data values. Don't include the label up here. Don't include the label. Just highlight all the values, and I do that by clicking and dragging across all of them. There's quite a few of them here, and you can see how many there are. It's 121 because we had 121 locators. And while I'm at it, I might show you a more efficient way of doing this. If you want, you can scroll down to the very first one, and just click on that cell, and then without clicking away but leaving that cell highlighted, scroll all the way up to the top and then depress and hold the Shift key and click the top value in that set, and that will select all of these together. Now what do we want to do? We want to sort these, and even though this looks slightly different on my program than it does on Excel, or than it does on the Microsoft version of Excel, it's still the A to Z, it's still the sort function, and so you click on sort, and the Microsoft version of Excel says from smallest to largest or from largest to smallest. This version uses the word descending from the largest to smallest. That's what you want. You want the largest to smallest, because that's what this locator corresponds to, is the largest value. And so you click on descending. Now pay attention to this, please. When you click descending or largest to smallest in the Microsoft version, the Windows version, you're given a choice. What it's saying is that you've selected some numbers that have some other numbers next door, and then it asks you, what do you want to do? Do you want to expand the selection, or do you want to continue with the current selection? You want to continue with the current selection, because if you don't, what's going to happen is all of these locators are going to follow all of these values here. And I'll show you what I mean by that in a second. So when I click sort, it orders all of these, and the smallest is at the bottom and the largest is at the top. Now if I did not do that, I'm going to restore this back to the way it was. If I did not do that, if I did not click continue with selection, this is what would happen. Let me pick a couple that are pretty close here. So I'm going to highlight these, the type in these two cells, or I'm going to turn it red so that it's easy to follow, so it's easy to see them. And now I'm going to select all my data values again. Sorry. Program's kind of jumpy. My mouse is real sensitive. Click the first, and then I hold the Shift key and click the last. Now I'm going to sort those again. Excuse me. I'm going to sort those again from descending, or from largest to smallest. And instead of saying continue with current selection, I will say expand the selection. I will click sort, and now excuse me, those two values follow along each other, and the locators are out of order. So these are in order, the values in the set, but the locators are not. So you don't want to do that. That's not useful at all. It's a little chaotic. So I'll just go back to the way things were and put them in the order that we want. I selected the first cell in the list. I go down to the last cell in the array, and I hold Shift and click that last cell. It selects all my data values. I click sort. I want the largest to the smallest, and I want to continue with the current selection. Continue with the current selection. It says sort warning. I don't actually know what it says on the Windows version. But it does say this: continue with the current selection, and you click sort, and now they're all sorted from the largest to the smallest, and they are next door to the proper locator. Now we need, for our box plot that I'm going to draw here, or kind of draw, halfway draw actually. I don't know, maybe I can draw it. I haven't practiced this. Anyway, we want the three quartiles, quartile 1, 2, and 3, and we want the minimum and maximum value. Well, the minimum value is at the very bottom. It's next to locator 1, and I believe it was 51 as I recall. Let me just make sure. Yes, so down there at the bottom next to locator 1 is 51, so that's that's my minimum value. And my maximum value, oops, sorry, my maximum value is, was it 126? 126. So my maximum value is 126. Now what I want is the values in between the three quartiles, and here's how I'm going to find those. It's really easy. So I choose a cell, and it doesn't matter which one, but I chose a cell in column M for Mary or Mamacita, and I type equal. And then I want the quartile, and Excel has a quartile function. It's, guess what, Q-U-A-R-T-I-L-E. And then I hit a left parenthesis, and I select the array, which is K2 to K122, I think. So I tell it all the values K1 or K2, and I enter a colon, and K122. And then I type a comma. Now what quartile do I want? Well, I want quartile 1, so I type a 1, and I close my parentheses and hit enter, and it'll give me quartile 1, which is 76. Now one thing I noticed just now, and I actually haven't done this with this version of Excel, with this Apple Macintosh version of Excel, is it didn't prompt me. When you, and now so there's quartile 1. I'm going to label that by putting Q1 next door to that. But when you, now I want quartile 2, and so when you type equal quartile, as you're typing that QUA, it'll give you an option. It'll auto-complete some functions. Just type quartile, and then when you type your left parenthesis, it will prompt you for the data values. It'll tell you number or array, and so that's when you want to put in the array, the range of cells over which all of these values are found. In this case, it's K2 colon K122. It's probably not going to be that on the exam. It'll be a slightly smaller data set than this, at least a little bit smaller. And then there will be a comma in place in the prompt. It won't be prompting you to put the comma, but there will be a comma there. You type a comma after the last cell in the set, and then it will prompt you for quartile. It'll say quartile 2, quartile 1, quartile 2, quartile 3. Well, all you need to do is just type the number 2 in this case. In the first case it was 1. Hit parentheses and enter. And I will do the last thing for the third quartile now, equals quartile left parenthesis K2 colon K122 comma and I want quartile 3, so I just type 3, close my parentheses, hit enter. Okay, now these are my 3 quartiles, 76, 85, and 92. I'm going to put them here. 76, what did I say? 85, 92. Let me make sure those are the right values. 76, 85, 92. 76, 85, 92. And now I want to mark them to scale on this number line. So, well, what is my scale going to be? What if each one of these lines stood for 10? Let me see what that would do for me. 50, I'm going to say this is 50, 60, 70, 80, 90, 100, 110, 120. That's going to be too compact. How about if each one of these stood for 5? Let me try that. 50, 55, 60. So every other one is 10. So this is 60, 70, 80, 90, 100, 110, 125. So that takes up almost the entire range. And so that seems like a good use of my number line. If each one of these stands for 10, so I mean it's for 5. So now let me see where my 126 is going to be. It's going to be 55, 60, 65, 70, 75, 80, 85, 90, 95, 100, 105, 10, 15, 20, 25. So that hash, the 4th hash from the right end, is where my 126 is going to be. Okay, so that's where my 126 is going to be. And now let's see where my other values are going to be. 55, 60, 65, 70, 75. So the next value is going to be about here. 55, 60, 65, 70, 75. 80, 85. So my next value is going to be about right there. And then 90 is right here. 92 will be just a little bit to the right of that. And then my 126 will be right here. Okay, so there's where my values are going to be. And now I just need to draw the box. And I'm not entirely sure how to do that. Something like this. It's a floating selection, so let me put it about right here. And what I'll do is I'll draw that over the number line, and I don't mean above, but I'll draw that on top of the number line here. And I don't really know how to do that here in this program. But anyway, that's what I want to do. Find those values on a number line and do it to scale. Choose your scale so that they're not all bunched together or way spread out, that they are actually on a scale just as if you had a ruler. And then draw your little square just like you do, or your rectangle like you do here. Make sure you put a mark for each of the quartiles. And there you go. There's your box plot. All right, now, as I mentioned in class, if you have questions, you can call me or text me at 464-5781. I also posted this on the Canvas website. It's right there on the home page. I don't mind if you do. In the evenings, you're less likely to get a response very quickly, but I will get back to you as soon as is convenient. So there you go. There's your review. And again, let me know if you have questions. Good luck. Please make an A. A's are easier to grade.